Hi there, we are looking at the second last question, and this question is on energetics, a total of 11 marks here, so let's dive into things. Okay, energetics is essentially how energy is transferred, energy is being absorbed or gained in that sense. So what we have here is a reaction between zinc and copper sulfate solution. And they say they put it in a glass beaker, they want to record the temperature, the zinc powder added is about this volume of copper sulfate, and then the highest temperature is reached. Okay, so just from here alone you would know that it is subtly telling you it's an exothermic reaction. So if you need a quick recap, exothermic reaction is one that the reaction give out heat, heat is released, heat energy is released, and this will cause an increase in the surrounding temperature. So setup essentially look like this. I'm going to try to draw a glass beaker, and then you have your copper sulfate in here, followed by a few drops of or zinc powder, not a few drops but like 5 grams of zinc powder. Okay, so they are asking for ways to improve to make sure that this is a more accurate, to get a more accurate temperature rise. So beaker is not the ideal choice here. The better option here is to actually use a polystyrene cup. Now, if you have done this experiment in school before, most of the time, actually I would say 100% of the time, you'll be given a polystyrene cup. How would polystyrene cup looks like? It looks like this. Alright, AED, it costs $34. What is $2,700 to get a polystyrene cup? I don't think so expensive. Alright, okay, but yes. So what we want to do here, we want to use a polystyrene cup. Okay, again, if you didn't catch that part, it looks like this. Okay, now why is polystyrene cup better? Okay, because it minimizes it is not 100%, but it minimizes heat loss. Okay, indirectly we are saying that this is a good material because it is acting as a good insulator. Okay, so just because this is a 2-mark question, first you just need to propose an alternative to the glass beaker, which is horrible. Okay, and then you provide the reason why. Now again, every time you see the word explain, you will need to go into the why. Okay, so here the bigger reason of why we want to use the polystyrene cup is either because you could just say that less heat will be lost, or polystyrene cup is a good insulator. You'll be able to get 2 marks here. Okay, all right. Then I'm going to move down to the next question. Give a reason why the student does not need to know the exact mass. Okay, here I'm going to move up a little bit. Okay, here does not need to know the exact mass of zinc powder. The reason is because zinc is in excess. Did they mention anything about it? No, they did not. Oh yeah, there we go. It's in excess. Okay, so it doesn't matter if it's like 1 gram more, 2 gram more, or 0.1 gram more, because there's more than enough zinc, so it doesn't really matter what is the exact mass that is going in. Okay, say the color change in the solution. So initially you have copper sulfate, and copper sulfate will be blue. You would have seen copper sulfate so many times, you will know that this is a very vibrant blue in color. But because zinc displaces copper, and this metal displacement here is an exothermic reaction. Okay, metal displacement reaction. So we no longer have blue in color. It actually becomes colorless. Okay, what you will eventually also see is you will see pink brown solid form. The reason why I'm writing this is this question can come out as a metal displacement question, and they can ask for 2 observations. So if they do ask for observations, you could say from blue to colorless, that's your 1 mark. The other mark goes into what is the metal, the color of the metal that's formed. In this case, is copper, so we say it's pink brown. Okay, so that's your 1 mark there. All right. Next, we have some data. So this is telling us the volume of copper sulfate solution. This is repeated twice. Okay, at the top they actually mentioned this already. They also talk about the temperature, initial temperature, and the final temperature. So with that, you know you need to do some calculation. And because we are looking at temperature rise, in case you didn't see it, so you know that this is an exothermic reaction. Okay, so with that, let's dive into it. Okay, so we want to calculate Q. Q is heat energy change. The formula for Q is MC delta T. One thing to always emphasize in my class is this mass actually refers to the mass of the solution. Some students confuse it with the mass of the solid, so they end up putting the mass of zinc over here, which is 5 to 6. In this case, which number will you choose actually? Okay, so it's actually the mass of the solution, which is 25, and then after that, C, it's the specific heat capacity of water, which is given to us. So that's our C is 4.2. It's always provided, so that's one thing you can be assured of. And then the temperature change is something that you can quickly punch into the calculator. You just basically do a subtraction. So if you have selected the correct M, you will end up with 3160.5 joules. Okay. Since they didn't mention anything about a significant figure, I would say just give like whatever you see on the calculator. If it's so nice, then stick to it. But other than that, you should keep to at least 2 or 3 SF. My personal favorite is to 3 SF for safety. Okay. All right. Next part is the final part of the question. Now this question here, take a look. I know I've got a lot of writing around it, but it's a 4-mark question. It is actually not a very difficult 4 marks, but you just need to be very careful on what they want. Okay, so the student repeat the experiment, calculate Q as 3,800 joules, which is very different from what we have, isn't it? So why is that so? Because the solution contains this mass of copper sulfate. Okay, now what you need to do here is to calculate molar enthalpy change. Basically, it's the energy released per mole of the substance, and in this case, the substance here is our copper sulfate. So since we have mass, and just do a triangle, okay, mass, mole, and then MR or AR. Okay, so we have given mass, we want to find mole. So what we want to do is we want to divide by the MR of copper sulfate, and MR, you see, is given to us. So a lot of hints and clues in guiding you what to do, but of course you need to combine them in the most accurate manner. So the first step you want to do here is to find the mole of copper sulfate. So you're using mass divided by the MR provided, and you should get a very nice number of 0.04 mole here. Okay, so with that, you're going to sub in the 0.04 mole at the bottom, because to calculate molar enthalpy change, again, if you're not sure, use the unit to guide you, isn't it? Okay, so you have kilojoules per mole, so that you know that. So indirectly, you are trying to put Q divide by the number of mole. So the Q given to us is 3,800 joules. What you need to do eventually is to make sure you convert it to kilojoules. So you can do that later or you can do it now. So in my case, I do it later. So I put Q directly with the unit of joules, and I divide it by 0.04 moles. So this alone is worth 1 mark. Okay, then I get my answers. My answers here at this point of time is joules per mole. So you need to take note of your answers. And then you want to convert it to kilojoules per mole. So most students will stop here, because there's so much things to read, right? And you would have gotten 4 marks here. But no, the final mark here is hidden in this line, okay? This line here that says include a sign in your answers. Now here, just by putting a minus subtraction, a minus sign in front of 95 will actually get you your 4th mark. And how do I know it's a minus, okay? Because for delta H, exothermic reaction is going to be minus, and if it's an endothermic reaction, it's going to be a plus. And since there's an increase in temperature at the end of the day, it's going to be an exothermic reaction, and therefore you need to put a minus sign in front of the value minus 95. Okay, so this 11 marks on energetic, has it been helpful? If it has been, then please like, subscribe, and share with a friend. We're going to last question, which is question 11. I'll see you on the one.